So one of the big ideas in this lesson is the difference between coordinate units and real units. So I've been pretty much touting this idea of the distance formula being the same as a ruler in the sense that it gives you the length of segments. But that's not entirely true. I mean, there's a subtle difference in the sense that the distance formula gives you a length of a segment in coordinate units, whereas a ruler would give you a distance in or a length in real units, for example, centimeters or inches. So this is a subtlety that I kind of want to drive home for students. So I would do that something like this. We might start with a segment like this, and I'd want to measure it. Okay, so we get the measurement of segment AB is 10 centimeters. So in this one instance, it turns out that the coordinate distance, which is basically 10 tick marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is actually the same as the real length, which in this case is 10 centimeters. So what that lets me know is that each tick mark is actually 1 centimeter. So now I want to shake that up a little bit, and this time what I'll do is I'll define a coordinate system again, but I'm going to change the scaling of the coordinate plane. So in other words, I'm using a different size graph paper. All right. So I do the same kind of thing again. I want to go and make that same segment. So here we go with that. So I'm going to go from here to here. And we can see that once again, basically this segment has a length of 10 coordinate units because it goes from 0, 4 to 10, 4. Okay, but when I measure the length, do we expect to see the length at 10 centimeters again? Okay, well, of course not. So it turns out that the length is 18.5 centimeters. And the idea that I want to drive home to students is that this lets us know that each tick on the graph paper is actually 1.85 centimeters this time because 10 coordinate units is equivalent to 18.5 real units, centimeters in this case. So then that gets us to the bigger question of what is it that the distance formula is actually telling us. So for example, when we have this segment here, if we were to measure its coordinates, okay, so I have C at negative 7, 4, and I have D at 6, negative 4. And if we plug that into the distance formula, it will give us an answer. And the question is, what is that answer really telling us? So what that answer will be telling us is the number of coordinate units. And we've established that each coordinate unit is actually equal to 1.85 centimeters. So then it would make sense to students that multiplying the coordinate distance times 1.85 centimeters would give us the real distance. So that's a subtle thing. In the years that I have been teaching, distance formula is something that never came up much. We just kind of gave the coordinate distance and didn't go any further. So this is definitely a distinction that I want to bring out for students. Anthony Carruthers, Better Lesson, Master Teacher Project. Hope this has been helpful.